Welcome again, Wildcats. All right, so today we're looking at Thursday, May 11th, and we're looking at trigonometry, sides, and angles, and that's going to be on page 83. So if you would, pause the video and update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. All right, so we're looking at trigonometry, sides, and angles on page 83. Okay, so first let's look at the steps to finding side lengths of triangles. Step 1, choose which trig ratio to use. Step 2, substitute it into the trig ratio. Step 3, solve to find the side length. All right, so if you would, update the steps for finding the side lengths. All right, now you have that. Let's look at finding angle measures of triangles. Step 1, choose which trig ratio to use. Step 2, substitute into the trig ratio. Step 3, solve for the angle using inverse ratios. Okay, so if you would, finish those up. All right, so now let's take a look at the examples. All right, so let's look at example number 1. It says, find the measure of each side indicated, round to the nearest tenth. Okay, so step 1 says to choose which trig ratio to use. So to figure out which one we use, we look at what we have. So we have the angle and we have the adjacent, so we're going to use cosine. So that's cosine of 37 degrees equals the adjacent, which is 11, divided by the hypotenuse, which is x. Okay. Step 2 says substitute into trig ratio, which we did. Step 3, solve to find length. So we're going to cross multiply, so we get x cosine of 37 degrees equals 11, divide by cosine of 37 degrees, so x equals 11 divided by cosine of 37 degrees, which equals, let me slide my chair back, get a calculator, and I'll be back in a Wildcat second. All right, so let's go ahead and put that in the calculator. So that is, now you can't see my calculator, but I assume if you're watching a video that you can use Desmos or whatever kind of calculator you have with you. If not, you can just wait until you get to class and put this in. But that is cosine of 37 degrees. Make sure your calculator is in degree mode, but it is 13.774. All right, so pause for a few seconds and finish up example 1. All right, so now let's look at example 2. Okay, so example 2, step 1 says choose which trig ratio to use. Okay, so we have, looks like we have opposite over adjacent, so we're going to use tangent. So that's tangent of 32 degrees equals opposite, which is x, divided by 13. Okay, so you cross multiply, so you get x equals 13 times tangent of 32 degrees. Which is 8.123. All right, I'm going to have you try example 3 in class on your own tomorrow, and then we can talk about it and go over it. And if I need to, I can go over those examples again, okay? All right, let's take a look at examples 4 and 5. All right, just find the measure of each angle indicated, round to the nearest tenth. All right, so first step is choose which trig ratio to use. All right, so it looks like we have, let's see, with respect to theta, we have the hypotenuse and the adjacent. So we're going to use cosine. So cosine of theta equals, the adjacent, which is 12, divided by the hypotenuse, which is 13. Okay, so now we substitute into the trig ratio. Now step 3, solve for the angle using inverse ratios. Okay, so what you're going to do is take the inverse of both sides. Okay, so that's cosine inverse of cosine theta equals cosine inverse of 12 divided by 13. Okay, now watch, I'm going to use a calculator in this case because we want to see. I'm going to show you what happens when you do cosine inverse of cosine. Okay, so let me clear out whatever is on this screen. Apparently there's lots of stuff. All right, so I'm going to do a super zoom in. And we have a little blurriness. Let's get that blurry zoomed out. All right, so I'm going to do trig, and I'm actually going to do cosine inverse of trig cosine, and I'm just going to pick some random, let's just do 5. Okay, now before I press enter, think about what's going to happen. Okay, all right, so what I want you to see is that the inverse and cosine left you with just the 5. Okay, and so that's basically the theta. So if we take the cosine inverse of both sides, we'll be left with just the theta. Okay, so this becomes just theta, so you get theta equals cosine inverse of 12 divided by 13. So, and you'll notice in your calculator it does have a cosine inverse. And so that gives you theta equals 22.620. Okay. All right, let me zoom out back here and let's take a look at example 5. Let me get the, there we go, got the blurriness away. All right, so now step 1 says choose which trig ratio to use. So we have here, it looks like we have opposite and adjacent, so we're going to use tangent. So tangent of theta equals opposite, which is 4, adjacent, which is 13. Okay, so now step 3, solve for the angle using inverse ratio. So we're going to take the tangent inverse of both sides. So theta equals theta equals tangent inverse of 4 divided by 13. So theta equals 17.103. All right, I'm going to leave example 6 and 7 for class tomorrow, and also example 8 and 9, okay? But again, I'll go back over any examples I did in the video again, if you'd like, okay? So with that, have a length and angle of a wildcat day.